Hello, so the notes for 2.1 here goes over the three forms of a quadratic, three most important forms that we'll be working with, and that the first one's standard form, the second one's vertex form, and then the third one's intercept form. All have their pros and cons to it, and we'll talk about all the details. And our goal over the next 2 days is to be as comfortable as you have seen these before, be as comfortable as possible with these, and given the info that we are given within a particular problem, know what form to use and what we do to move from one form to the next. So how do we move from standard to vertex? How do we move from standard to intercept? Also, how do we move from vertex to standard or vertex to intercept, and so on. So we'll talk about that. So first off, for the first form, ax squared plus bx plus c, this is the standard form of a quadratic. A is a coefficient of x squared, b is a coefficient of x, and c is a constant. We want to find the y-intercept, as we do with whether it's a quadratic or any equation or function. We plug in 0, and so when we plug in 0 and for f of x, in this case, it will equal c. So what's nice about standard form is whatever your constant is, since 0 goes in for x, the a and b terms, the x squared and bx terms are going to cancel, and you're left with c. To find the x-intercept, you set equal to 0, and as you see, this is standard form of a quadratic, so then we will have to use different methods to find the solutions. We could either factor, complete the square, which we'll work on later, not today, but tomorrow. Actually, will be in this video today, but it won't be applied till not tomorrow, but Monday. And the other would be the quadratic formula. If we want to find the vertex, which we'll talk more about why this is, if we want to find the vertex of the parabola, so if our parabola is like this, the point at the bottom or the point at the top, the highest point if it's facing down, the lowest point if it's facing up. To find the x value of the vertex, we go negative b over 2a. So we do the b value, plug that in there, the a value, plug it in there, simplify. That gives you the x value of the vertex. And then we take that and insert into the function to get the y value of the vertex. That's what that means. If I have a parabola like this, axis symmetry is a vertical line going through the vertex, and a vertical line is always x equals, and the x value at the vertex will be this. So if that's the x value at the vertex, that's the x value for every point on the line. So therefore, the equation of the axis of symmetry is x equals negative b over 2a. If a opens up, then the parabola is if a is greater than 0, that means a is positive, which means the parabola is going to open up. And the vertex then is at the bottom, so it is a minimum point. Again, imagine the parabola looking like this. If a is less than 0, that reflects it over the x-axis, and therefore it's facing down. Parabola faces down, and the vertex then would be a maximum value. If a is between 0 and 1, or between negative 1 and 0, that's going to expand out the parabola. So if here's my standard parabola, if it's between 0 and 1, it's going to expand it out. We actually looked at that when we were working on the, again, horizontal expansion. Don't think about vertical expansion or contraction. I think that's confusing, and for all functions, it's better to think about it in terms of horizontal. When we were doing, back to what I was saying, when we were doing transformations, we looked at expanding and contracting, and that's exactly what rules we're following here. Same if a is greater than 1 or a is less than negative 1, that's going to condense it, because essentially it's going to be going up faster because you're multiplying it by a number greater than 1. And if it's negative 1, that condenses it, but also that negative also flips it. So there's two things going on there. Note, a is a vertical distance up, down when moved left to right, one value from the vertex. So let's imagine if my vertex is right here. And let's say I have f of x equals 2x squared plus whatever. Doesn't really matter from there on out. Now what we do is we always move, and we can test this later as to why this works. If this is our vertex, we go 1 unit to the left and 1 unit to the right. I go 1 unit to the left and 1 unit to the right. I'll do one at a time. If I move 1 unit to the left, you always move left and right 1, and then you go the a value up or down. Since it's positive 2, we are going to go up 2. So we can always graph the 2 points that are 1 unit to the left and right from the vertex by going over 1 and over 1, and then going the value of A up or down. If it's positive, we go up, and if it's negative, we go down. So that point would be right there, and that point would be right there, and then we could get a good sketch of the graph just simply based on knowing where the vertex is and the value of A. Now, if we move to vertex form, what vertex form is a x minus h squared plus k, where the vertex is h comma k. The y-intercept would be plugging in 0 in for x. So when you plug 0 in for x, you are then just going to, you'll get, let's see, it would be something look like this. The x would be 0, so negative h squared would turn to h squared plus k. And you don't have to remember that it's h squared plus k, but those would all just be numbers, and you simplify it, and that would be your y-intercept, which isn't that difficult, but it's not as nice as standard form in terms of finding an x-intercept. To find x-intercept in this case, I said x-intercept, I was talking about y-intercept. So if we look in this case, what we would do is simply solve for x. So you'd solve for x by subtracting over k, dividing by a, and then square rooting, and you get a plus or minus. So, and we'll go through that process. Solve for x, and that gives you your value. We'll go through that process in some problem. What's great is a follows the exact same rules as it does in standard form. So this rule right here follows for a as well. So if you're in vertex form, you do the same thing. Once you have the vertex, you go over one to the left, one to the right, and then you go up or down the value of a. Intercept form. This is called intercept form because if you plug 0 in for f of x, your solutions would be x equals r1 and x equals r2. Note we have that constant out front, a, so typically we're used to looking at factored quadratics. You don't have to write this. Example like this, and let's say it's equal to 0, our coefficient of a is 1, but a could be 2, it could be 3. In any case, that doesn't change the intercepts there. And we're going to explore this as we move forward. So, let's see here. So we want to, what's good about this form? One thing is it's very easy to identify the x-intercepts, the roots, the zeros, and the solutions, which all are synonymous terms. All of these x-intercept, roots, zero, solutions are all synonymous terms. And if we set those equal to 0 and solve, we get x equals r1, r sub 1, and then x equals r2. We're not going to go into details as to why it's named those things, but we'll talk more about that in class. If we are finding the y-intercepts, we plug 0 in, and then we would simplify for x. The way that would look would be a 0 minus r sub 1, 0 minus r sub 2. Note r1 and r2 and a would all be numbers, so like r1 is 2, r2 is 3, that would be negative 2 times negative 3, which is 6, and then multiply it by whatever a is, and that will give you your y-intercept. So I'll just put arrow, simplify after you plug in. Sorry, my stylus is very catchy right now, so it's kind of hard to write nicely. Hopefully it'll improve. To find the x value of the vertex, well, let's go ahead and we're going to explore this more. But if we look at, let's say, a parabola right here, and let's say here's our vertex, and here are the roots. What we find for any parabola is that this x value of the vertex ends up being the midpoint of those. So in order to find the x value of the vertex, we take r sub 1 plus r sub 2 and divide by 2. To find the y value of the vertex, once you have the x value, simply plug in x, which is at r1 plus r2 divided by 2. Plug in x and simplify. A follows the same rules as above. Okay, if this is day 1, you are going to skip this and move on to problem 2. For day 2, you will come back to this part of the video to watch going from standard form into vertex form. Okay, that being said, let's just do a quick analysis of our standard form, vertex form, and root form. How would you go from one to the other? Well, standard form, and you don't have to write this down, standard form to vertex form, that's what we're going to do here. Standard form to root form, you would factor. If we're in root form, to go to standard form, you simply FOIL out, distribute out, combine like terms. In vertex form, into standard would be the same. Note, if we're in vertex form and you want to get into root form, the way that you do that is first FOIL out or distribute out to get into standard form, and then you go into root form. That would be the same going from root to vertex. So standard form is your intermediate for all of that. So you've seen this process before, but I'm sure it's been about a year since you've done it in Algebra 2. What we want to do is get in the form of a x minus 8 squared plus k, and if you look back at that x minus 8 squared, that's a perfect trinomial because it factors into two binomials that are the same. That's the definition of a perfect trinomial. Well, that's what we want to do here. We want to create a perfect trinomial, and in order to do that, we're going to group the first two terms. Now, a side note, if I had, let's say, this is just a quick review over how to create a perfect trinomial. Let's say I have x squared plus 10x plus 25. We want to know what number would go there so that x plus whatever would be the same. Well, one way we could look at it is we go, well, we want this number to be the same, and what number times itself, or and what number times 2 would give you 10, or what number added to itself would give you 10, and that's obviously 5. So if you look here, the perfect trinomial that we could create if our middle term is 10, would be 5. Well, you look and you go, well, if I have x plus 5 squared, 5 times 5 gives us 25. So if we are given this, what do we do to 10 in order to get that number 25? Well, I took 10 and I divided it by 2 to get 5, and then I took 5 and squared it to get that. And the reason we do that process is because that's what is necessary in order to get a perfect trinomial. That this number at the end is going to be the middle number divided by 2 squared. So coming back to our problem here, if we have 2x squared plus 8x, in our other quadratic it was a 1x squared, which would make it much, much more easier to work with. So it is possible to get a perfect trinomial with a coefficient in front of x squared different than 1. It's much, much easier in front of it if a is 1, and also we'll see it beneficial to pull out that 2 anyway. So we're going to factor out that 2 there out of both of those terms, and that's going to give us x squared plus 4x on the inside. Now we want to add a term in here in order to get that perfect trinomial. But there's a problem. If we add a term that is changing up the function, the only thing that we can add to this whole side that wouldn't change up f of x would be a total of 0. But we don't want to add 0 here because that doesn't create our perfect trinomial. Well, let's say the number was 10. If we added 10, we'd also have to subtract off 10, because then that would equal 0. So whatever we're adding here, we also have to subtract, and we have that all inside the parentheses, and then we have the plus 7 on the outside. So now what we do is that process that I mentioned in that quick review, that we take the b term, we divide it by 2, and we square it, and that's going to be our term right here that will create our perfect trinomial. So note, this is with the 2 factored out. We're just looking at this quadratic right here. If I take 4, divide it by 2, that would be 2, and then I'm squaring it, would be 4. So 4 divided by 2 squared gives us 4, and we also have to subtract off that 4 so that we're adding 0 to the function. We're not changing what it is. Now, this is our perfect trinomial on the inside. That's what we want to be our x plus b squared, or x plus whatever variable, d squared. But we want this to get out of there. We don't want that inside the parentheses because these three terms are a perfect trinomial. So what we're going to do is pull this term out, but we have to be careful here because the true value of that is really whatever, all the terms in here, the true value of it is all of these times 2. So if I'm pulling this out, the true value of this -4 is -4 times 2. So I'm really pulling out a -8. And now we can cross that off. Now if we simplify this, I'm going to go step by step. We have an x squared plus 4x plus 4. There's our perfect trinomial. We pulled out the -4. We multiplied it by 2 because everything inside the parentheses is being multiplied by 2. And then on the outside we see we have a 7 minus 8. And we can combine that to be -1. And I forgot, but you all may have noticed that I forgot the squared there. Oh wait, there shouldn't be a square there. That's correct. Oh, I'm just being fallible. Okay. So now we are going to factor that quadratic. What multiplies before and adds before, that would be 2 and 2. So we also know the different ways we could figure this out is taking this term divided by 2. If this is a plus, it's a plus. If that's a minus, that's a minus. We can talk about those details. Or you simply take this plus 4 and divide by 2. If this is -5, this would be -5 over 2. And then we have a -1. So now that we have, that's how you go from standard form into vertex. We want to find the vertex. Well, the vertex is hk, which is x minus h, so minus -2 would be h. Minus h would be minus -2 since it's x plus 2. And then k is -1, so there's our vertex. We also want to find the axis of symmetry. We'll just put AOS. Axis of symmetry is x equals the x value of the vertex, which would be -2. And then we are going to graph it. So if we go to the coordinate -2, -1, we graph that. Sorry, I'm getting some disturbance in the connection here. Hope it's not messing up the video. And remember, we can use our, there's 1 point, and then we use our a value to figure out 2 other points. We start here, and we always move 1 to the left and right, and then we go up, down the value of a. Well, a is positive, we're going to go up 2. Then if it's -2, we go down 2. So we're going to go up 2, and we're going to have a coordinate right there. And then we do the same on the other side, which gives us a coordinate right there. And then we're able to sketch a graph fairly reasonably. Okay, if you're watching this for day 1, you're going to continue on from right here. Number 2, determine standard form of a, that's supposed to be parabola, parable, or parable. I think it's parable. Anyways, parabola given the vertex is 3, 4, and a point on the parabola is 1, 2. So if we're given the vertex and a point, I think vertex form would be useful for us. It's supposed to have an A out front here. Of the 3, because we simply have the vertex. The vertex is 3, 4, and that would go into hk, and then the point 1, 2 would go into f of x, or x comma y, and then we have 1, 2, 3, 4. We have all those filled in, and we solve for a, and then we could write the parabola. But it says given in standard form, so after we get it into vertex form, we'll then go ahead and solve. So let's go ahead and do that. So first thing we're going to do is we're going to substitute in 2 for f of x, since that's our coordinate x comma y. A, we don't know. X of the coordinate would be 1 minus 3 for h squared plus 4, which would be k. And we could have plugged hk in for xy, but we can't plug that xy coordinate in for hk. So that's why we plug in the hk coordinate for hk and the xy for xy. And now we go ahead and solve for a. So now we have a, and that'd be -2 squared, which is 4. We could have written that as 4a plus 4. Subtract over the 4 gives us -2, so we have 4a. And then we divide by 4, so a equals -1/2. And then we're simply going to rewrite the parabola. F of x equals -1/2 Negative 1/2 x minus 3 squared plus 4. Now that is vertex form, but now we want standard form. So we need to distribute this out. First we need to square the x minus 3, which would be x minus 3 times x minus 3, which is x squared minus 6x plus 9 plus 4. Distribute in the half. Equals, distribute in the half will give us negative half x squared. Negative 1/2 times 6 will give us positive 3 minus 9 over 2. And I want to combine that with the 4. I'm going to turn 4 into 8 over 2. It'll get like denominators. And then we go ahead and simplify. That would be negative 1/2 x squared plus 3x. And if I have negative 9 of them plus 8 of them, that gives us negative 1/2. Don't think I made any mistakes in that, but that's the process to get to standard form. Okay, next. Height of a football when punted is modeled by all of that, where x is a horizontal displacement. So how far it would travel. So if a ball is following a negative x squared, that would be an upside down parabola like this. So it's saying x is the distance it travels horizontally and y is the displacement vertically. And we want to know how high the ball is punted. So let's say the graph looks something like this. We want to know the height at that point. Well, that would be the y value of the vertex. So since we're in standard form, we can use that formula negative b over 2a. And b would be 9 over 5 over 2 times a, which is negative 16 over 2025. And that, just make sure you plug into your calculator correctly. And I think I did the calculations correctly. That gave me an x displacement of approximately 113.9 feet. And then we want to substitute that in for x to find out what y is. So when we substitute that in, we get for y approximately 104 feet. I think that's right. I did it on my Apple calculator. Kind of in a crunch for time here, so I apologize for that, but that's simply plugging in the x with just those nasty fractions. Oh, by the way, I did that backwards, fallible human being. I just found what the maximum height of the punt is, so that would be the maximum height of the punt. How high was the ball when it was punted? Well, that is when 0x displacement has been made, so we plug 0 in for x, so that would just give 1.5 feet. Which is nice again, because remember the y-intercept when x equals 0 is simply c. How long is the punt? You are going to plug 0 in for y. And I would suggest doing this on your calculator. What you can do is you plug that in and do trace. Or I don't have an 84 function on my iPad where I'm recording. But obviously you're not going to factor that or use a quadratic formula. That's super nasty. We could just do it using the max-min function on your calculator. I can go over this in class with you. The max-min function or trace. Depending on what your steps are, how often you're calculating x, trace can get a fairly good representation of that. I'm guessing it's somewhere in the 230 distance. Oh no, yeah, 230 or so. It's going to be about double that right there, but not exactly.